Hello everyone, and welcome back to part 2 of our Getting Started tutorial for Fluid Solid Heat Transfer Simulations in Ansys Discovery. In part 1, we focused on the setup of our simulation, which can be seen on the left side of our screen in our physics tree. Part 2 is going to be focused on solving the simulation using our live GPU solver in our Explore mode, and we will be post-processing these results. Let's go ahead and dive on in. To solve a simulation in Ansys Discovery, simply navigate down to the bottom right corner of your screen to your results arc. The Solve button is the green button in the center, so let's go ahead and click this now. Within a few moments, we are beginning to see some preliminary results of our steady state solver. As you can see, a white dot is moving around the outside of our simulation information display, indicating that the solution is still progressing. When it stops, the simulation is complete. As you can see, we are looking at a contour plot of the temperature distribution in this assembly. You can tell that the contour plot is activated by looking at the contour plot, but also by looking in our results arc where you can see the blue arc above our contours icon. On the right side of our screen, you can take a look at the legend to understand the values that are associated with these colors. Additionally, if you wish to understand a local value, you can simply hover over the geometry and you can see that it will isolate a specific value. If I hover over one of the warmer areas, you can see that the value is 44.9 degrees Celsius. Ansys Discovery has a very valuable feature that aids in post-processing and is called our Save Scenes feature. This will save the result type as well as the orientation for future utilization. So let's go ahead and save this scene here so that we can use it for future use. To save a scene, simply navigate to the top right corner and click this button here and it will save the scene. Let's go ahead and take a look at some other post-processing options, maybe outside of our contour plots, but let's go ahead and briefly touch on a few more options here. On the right side of our screen in the legend, you have the opportunity to change both the variable that's being shown, in this case we're looking at temperature, but you also have the opportunity to change the unit here as well. So for instance, if I wanted to go ahead and change this over to velocity, you can see that our velocity contour plot is now showing just on our fluid domain because there's no velocity in our solid components. But let's go ahead and look at a few other post-processing options here. Let's turn off our contour plot by clicking this icon here. Next, let's go ahead and review some of our other post-processing options, and as you can see, we have a multitude of other options. If you're not sure what any of these icons mean, you can pull up our overlay help system, which is context sensitive, by hovering over an icon and hitting F1 on your keyboard. This places a vignette over the screen, which allows you to go ahead and get more information based on where your cursor is located. As you can see, I can move to different objects and the help will update. Even the sub-menus will have context-sensitive help as well. If you wish to close this, you can simply click this red X in the top right corner or hit F1 again. Let's go ahead and take a look at some of our other results by navigating down to our results arc where we can select a different option. In this case, let's go ahead and select our particles. Let's go ahead and click this icon here. As you can see, the particles will show the directionality of the flow, and they're going to be colored with respect to the variable that is shown on our legend. As you can see, right now we are looking at velocity, so let's go ahead and reorient our geometry using these click options down here in the bottom on this origin, and you can see we can rotate our geometry so we can look at the bottom of our flow channel here. Let's go ahead and look at some of our options that we have with respect to our particles. As you can see, we can control the size of these particles, we can control the animation speed, the speed at which they go through the flow domain, or we can go ahead and limit the range. This range mirrors the values on the legend, and if I wish to eliminate low flow velocity particles, I can simply drag this bottom value up, and as you can see, it's only showing high velocity flow regions. Or I can do the opposite to identify any areas of slow or stalled flow velocity. Let's go ahead and save the scene for the sake of example by going ahead and clicking the Save Scene buttons once again. Let's go ahead and also take a look at some temperature plots on this particle emitter as well. So let's go ahead and navigate up to our legend, click these three buttons, and let's go ahead and change to temperature. As you can see, the maximum value of the legend is tied to the global domain, which is a bit too much for this flow domain, which is much cooler. You can change the peak value of the legend by simply clicking in this text box and typing a number, or you can hover over here, and as you can see, I get a double arrow, which allows me to click and drag the value. As you can see, the legend will go ahead and change its values, and the colors will change associated based on the results. Now, if I wish to go ahead and view this maybe as another save scene, I can simply click this button up here once again. Let's go ahead and turn off our particles by clicking here and going ahead and turning on our contour plot once again. As you can see, if we hit H on our keyboard to go back to our home view, everything is colored red based on the change of our legend value. You can simply reset this by typing the value once again, or by clicking or hovering over this cogwheel and clicking this reset, and it will go ahead and reset our range back to the default values. Now that we've went and reviewed a little bit of some of our results, let's go ahead and make some changes within this application. As you can see on the left side of our screen in our physics tree, we are working with a structural steel definition for all of our solid components and water for our flow domain. Let's go ahead and change some materials and see the subsequent change in our results. Right now, these IGBTs are of a structural steel definition, but they should not be structural steel. They should be silicon. So let's go ahead and change this. To change materials in Discovery, you can simply select the piece of geometry by triple clicking to select the body, and then you'll see a heads-up display will appear, which allows you to go ahead and change the material. Clicking this arrow here will expose our material library, and as you can see, we can scroll down and select silicon here. So let's go ahead and change this for the first IGBT. As soon as I do that, you can see our simulation has restarted, which will go ahead and prepare some new results for us. But we want to go ahead and change the material definition for the other two, so let's simply triple click to select this body here, and hold Control, and then triple click to select the second body. From here, we can go ahead and select this drop down, scroll with our mouse, and select silicon once again. This will provide us with the correct material definition for all of the bodies in our domain. As you can see here, our simulation is still processing, but hopefully it will be completed here shortly so we can review the changes in our results. As you can see in our legend, the peak temperature in our domain has decreased. I believe it was about 47 degrees previously. Now, it might be a little bit difficult to remember these values, but we are recording these automatically in our monitors. In the top right corner of your window, you can see our monitors icon. Clicking this will expose our monitors, and in this case, these are the three monitors that were created by default based on the types of physics we are solving. We have a fluid portion, so we're going to go ahead and get max velocity and pressure drop, and of course we have a thermal component so we can see our max temperature. Clicking any of these charts will go ahead and bring up the chart, which allows you to go ahead and review the values that were created on each simulation. The first one is our initial results. The second one here is when we changed the first component, this first IGBT to silicon, with the rest remaining steel. And this last one here is with all three IGBTs with silicon. As you can see, these were created automatically, but if I wish to create a new one, I can simply navigate to the top center of my screen to the monitor section, where I can go ahead and click this drop down, choose one of our predefined ones here. These are created by default, or you can click this custom one. Custom allows you to select a piece of geometry. In this case, let's triple click to select this IGBT. And then from here, you can go ahead and select a variable. Maybe I want to know the average temperature on this last IGBT, so let's go ahead and click this check mark to confirm. As you can see, it is now preparing a value of the average temperature of this body, which is 37.8 degrees Celsius, which is indicated when I hover over this. Let's hit escape a few times to go ahead and close our heads-up display, and let's click this X to close our monitor here. One last thing that I wanted to do in this application is to make the bottom face of this cooling plate to be insulated. I can do this by simply clicking and holding my middle mouse wheel button and rotating my geometry. At this point, I can select the bottom face here with a left click. I can navigate up to my hex, go into my halo here for my solid thermal conditions, and as you can see, we have a variety of options. The last one here will allow the face to be insulated. So let's go ahead and click this here and click the check mark to confirm. Let's hit H to rotate back to our home view and hit escape to remove our selection and close our heads up display, and we should be getting to see some results here shortly. As we can see, the temperature distribution in this domain is relatively the same, but we are seeing a slight change in our temperature. If we go ahead and take a look at our monitors, we're giving you arrows indicating how the values changed based on the change in your simulation. As you can see, the peak temperatures slightly went up, but this is more representative of the performance of our application. This concludes part 2, and in part 3 we'll be focusing on utilizing our refine mode, which utilizes our Ansys flagship solver of Ansys Fluent. Be sure to tune in for part 3. We'll be covering the last remaining pieces you'll need to get started with conjugate heat transfer simulations in Ansys Discovery. Thank you and take care.